This week on Let's Make It, we're going to show you how to attach an RFID reader to our previous project of code entry to have two factors letting people into your building. Coming up. Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Welcome to episode 15 of Let's Make It. And this week we're going to kind of revive an old thing that we did and add some things to it, but in the process you're going to learn about RFID. So first let's talk about what RFID is, and you're going to see right here I have these cards, and if you work somewhere that you have a badge to get in and out of, you probably are used to seeing like a picture printed on this or something like that. These are just blank cards, but these are RFID cards, and there's no mag stripe on them, so they're basically when you get close to a reader of some kind to let you in the door. If you wipe to get in your building or whatever at work, then this is not the same thing as the RFID. Basically, RFID is a wireless technology that uses the power of a radio basically to turn this little chip that's on here. And if you can't really see inside this necessarily, but if you could, you'd see a bunch of wires wound around and a tiny little chip that when it gets to the RF signal, it's enough power to turn the little chip on and it transmits out its code. Now, what we're going to do today is we're going to take one of these and we're going to write a program that provides access to basically the same thing as a door lock like we did before. So, I'm going to revive the project we did. I think it was episode 13 or 12 where we did the keypad entry to do a lock. And I'm actually going to add to that project the ability to use this. So why would you want to use a keypad and a card? And it's called two-factor. And the whole idea of two-factor is it's something you have and something you know. So you know your passcode. And if somebody else would get that passcode, they could go get in without you. But if you have this on you, and your passcode, it's double the protection. So somebody could steal your card, but they don't know your password. So they have something, but they don't know something. So they're considered two-factor. If you do it on a computer, they call it two-factor authentication. It's just double the protection. Passcodes can change very regularly, and you can keep the same card for a long time. And you typically protect the card because it has your identity and everything on it. So it's something you have with the card and something you know in the PIN, which is your passcode or your PIN. So, but before we go there, we're going to talk a little bit about the RFID. Now, this is like I said, it's an RFID card. Everything on here has a code assigned to it. They call it a tag ID. And I'm going to use a RFID reader from Parallax. You can go to parallax.com and look up RFID reader. I'm using the blue one. It's a read-only Parallax RFID reader. They do have a read-write one now. I think it's black. This will not work with the black one, just so you know. So let me go ahead and I'm going to pull off the reader real quick and go to the camera in the Arduino and show you what we have over there. Okay, so here we see our kind of Frankenstein project we had before. Here's the keypad right here. I got stuck on it here because it's flat. Here's our display. And this blue thing, which you can't see because it's way thin, is the RFID reader. I'm going to pull it out and show you what it looks like. Trying to be careful pulling it out. There we go. So, by the way, I did pull out the pin to the power to the USB. So this is the reader, and you see, I don't know if you can see it on the camera, see if I can get it. Oh, there you can see it. See the little lines of wire going around? This is basically the antenna. Now it's on both sides. See, it's on this side as well, right there. And there's not much to the electronics part of it. A couple chips are here, and I don't know what the chips they are. I haven't really gone through it, but basically the concept is it sends out a signal, a power signal, that powers up the card or whatever kind of tag you have. I'm going to show you another kind of tag here in a second. And the tag starts transmitting out its code, and this receives the code. And what it does is it sends it back to the serial port. So you see there's 4 pins here, and the 4 pins are 5 volts, ground, and enable pin, which basically says it's either it's reading or not reading, and then the data, which is serial data. This particular card sends out serial data at 2400 baud, so it's very, very slow compared to today's technologies, but you're only sending out a few digits, so it's actually fairly quick, and it works well for that. This particular one was designed for Parallax, which is by Grand Idea Studio. I can't remember the guy's name. His last name is Grand, obviously. So it's basically real simple to use. And again, it just as it sees a card that gets close, like you see a card like this get close, it will read the card and send you back the number. Now the thing is, it keeps sending it as well, and you're going to see it as that can be an issue, which we deal with in our code. And you'll see that during the first demonstration of this, because we actually have the first program we're going to look at is one that just reads the data and displays it to the screen. So let me plug this back in and get power back everywhere here. All right, so I showed you these cards right here, these cards, and they're blank white cards. You could print on them if you had a card printer. But I want to show you another kind of RFID tag, and that is this little plastic thing. It goes on a keychain. You see it's on my keychain. And I did this for another project, and I've actually used one of these before, these Parallax cards, but I did it with a PIC chip to turn off and on a sound system by having a valid key like this. So anybody is allowed to do it one of these, they can go in and turn it off or on, and it works very well. But this is also one you can stick on your keychain, and I'll show you this. I actually set this up in our demonstration for today as one of the valid keys. So, all right, so what I'm going to do is I'm going to show you a little bit about what I have done. So I have this stack of cards, and I've taken 3 of them, and hope they don't mind, but some of our other hosts on our shows, I use their names. So here's Dennis, and I've written on this sheet of sticky paper, which you can't really tell probably, but it's a sticky note, and this is Dennis. Let me go back to the other camera so you can actually see what I'm doing, so you kind of get an idea what's going to be going on. You can see on this white card, I have Dennis's name, and I've assigned him just a random number as a pin number. And you see I put it on the bottom here. In his case, it's 9876. And I've done the same thing with 2 other random numbers, one for John, right there, and one for Michelle. And we're going to see how this works in the program later on. So I just want to make sure you understand as we get in there, if I don't forget to tell you about this part of it. But our first thing we're going to do, and it's running right now as we're sitting here, is we're going to look at what comes back from the card when the Parallax sees it. So let me reset this. And I don't know if you can see that when I reset that, but there's a little red light on the Parallax reader here. Red means it's reading. Green means it's not. So I'm going to go and put a card close. And let me bring the camera in a little bit closer. So hopefully we can see this. Let me move all this down a little. Okay, you can't really see that very well, but what you're seeing is the code. So in this case, the code is 0F0296A EEE. This is that particular card. It's not a card that I'm using, but that's the code that comes back every time you do it. So if you see on here, if I keep doing this, you see another one, you see another one. Actually, because it's better if I do this. No, not really. Just want to figure out a way to get you to see the screen better. But you can see it keeps reading the card, and any card I grab is going to do that. And what it's sending back is a line feed, a 10 is line feed, yeah, line feed, and then the code, and then line feed again. That's like the beginning and the ending of the code that comes back from the Parallax reader. So you can always look for the 10, so you know it's starting the next number. So that's like the what do you call that? The delimiter, and it goes in between each. So In our code, you'll see how we actually use that to know when to start reading again. I will say that this reader seems to be a bit noisy. Sometimes you just get garbage out of it. And I'm not quite sure why, and we had to deal with that in our code a little bit. And actually, I'm going to give you 3 pieces of code today. I'm only going to talk in detail about 2 of them, but the third one deals with it the way I think it should be dealt with in the real world scenario versus my demonstration. So right there you see garbage come across. That was EC02 and a bunch of zeros, and there was no card close to it. It just picked it up. So it doesn't follow the right format either necessarily. So I just got garbage. Don't know why that is. I mean, I've had that in multiple environments now, so it's picking up something from somewhere. I just don't know what it is. So let's go ahead and let's walk through this program real quick, and we'll show you how this program works. This is like the basis of our other programs. All right, so what we're looking at here, and this is going to be on the show notes, is the read RFID, and this really is a very simple one. And you see I basically include the wire and liquid crystal because I'm displaying it to the screen. I could just as easily just done it to the serial port, and it probably would have made a little bit more sense. I'm actually don't even need to define the num anymore. So something I was doing before. Let me get rid of this so it's less confusing. So I do liquid crystal, I define the LCD, do setup. Remember I said this thing uses 2400 baud, very slow. So I do a serial.begin at 2400. I init the LCD, I turn the backlight on, I do clear screen, and again, I don't need this anymore. And then what I'm doing is I'm taking and setting pin mode 2, which is connected to the enable pin. And I probably should I'll go over that again here in a little bit when I get to the next program. But I have pin 2 connected to the enable pin of the RFID reader. So I set it to output and I turn it low. Low makes the reader come on. Seems a little non-intuitive. High basically says that the reader is not reading, low says it is. But you set it to low and it turns it on. And then all we're going to do is we're going to sit here and we're going to loop and look for serial input. And that's all I'm doing. Every time I see a serial, something come in the serial port, I'm just printing it to the screen. So it's very, very simple. It just outputs exactly as what serial. And you'll see if you look at the actual screen, you'll see those funny characters in there. In between, you see it's got more garbage since we switched away as well. Those funny characters are the line feeds. So I actually think it's a line feed in the beginning, character turn to the end, something like that. Something similar to that. But that's it for the program. And then you see clear screen, which I have down here. And let me just say, I've experimented with the clear screen for this LCD. And every time I do it, the LCD gets messed up. So I do not use the command for clear screen on this LCD. I don't know what it is, but I'm doing the LCD.command LCD underscore clear screen. And every time I do that, it just like locks it up or something. It just does weird stuff to it. So I've been manually doing this printing to clear the screen. That's why you see that in there. I know it's not very efficient, but that's just the best way it works. All right, so that is this simple program. Let's go look at the Arduino again, and I'm going to show you how I have things wired, just so you have a reference to how they're wired. So we have the LCD, and we're using an Arduino Uno. So with the 2-wire LCD, I have power running over to this bus. I have this whole breadboard bus powered from the top down, and then I have the clocking and data going to what is analog 4 and 5, and that's where that works on the Uno boards. And then over here on the right, you see I have this mess of cables right here, little plugs, and this is all for the pad, number pad right here. So it's the same wiring as we did in the previous show, same pins and everything. So you can go back and look at that show if you want to know how it's wired up. And then down here at the bottom, I have on pin 1, this yellow wire, which is the serial input from the RFID. And then on pin 2, I have this white wire right here, and it goes to the enable pin. Let me bring this down. The enable pin on the RFID, you can barely see it because it's right above the camera, but there is an enable pin, and that's how I control that pin 2. Is through that enable pin. All right, so that's how it's wired. So now I'm going to go push this up a little bit, see the screen a little bit better, and get our pad down here because we're going to need the pad. And I want to walk through, I'm going to load the other program in, and let me just say with, I had trouble getting this to work with the Leonardo, and I think it's because the way the serial port works on the Leonardo, it wasn't ever seeing the serial data from the RFID. That is what I started with, was the Leonardo, and I went through a bunch of different iterations and just couldn't get it to work. So I said, well, knowing that the Leonardo has the USB serial back and everything, let me just try a different one and see if that's the problem. And that was obviously the problem because it worked right the first time. So I may go back at some other time and try to figure that out, but I may not use as well either. So let me go ahead. But what I was trying to get to was to upload to the Arduino, you have to unplug the serial plug from the RFID. So let me pull this out. And then I'm going to upload a different program. And let's see. It's uploading and it's done. All right, so what I'm going to do is I'm also going to enable my serial monitor. And the other thing I'm going to say is that you'll see this go off and back on again. And that is because I'm very close to using the maximum amount of power from the USB to power both the LCD and the RFID when they're both on. All right, so we're going to do a demonstration here. And right now you see on the screen, it's saying, let's make it two-factor auth project, scan tag. Well, I can't see this so good today. All right, so scan tag. So what I'm going to do is I'm going to take, here is John, and you see his code is 1245. So I'm going to scan the tag. And you see it says, welcome John, please enter your secret code. So I'm going to enter 1, 2, 4, 5. Access granted, welcome. Okay, so now what I'm going to do is I'm going to put an invalid code in. Here's the same one, John. There's John, and I'm going to start with 5. Access denied. So this is working very similar to what we had before, with the exception of I have to scan the badge first. So John is 1245. Let's take another one. Here's Dennis, and Dennis is 9876. So I'm going to do Dennis, and I'm going to put in John's code. Oh, it's invalid. So you can see that the code is not fixed. It's based on the actual card itself. So again, 9876 is Dennis. So I'm going to scan Dennis. Hold on one second. Invalid card. So we're going to talk about, it probably just got garbage. You saw it said invalid card. It probably got some of that garbage. And it displayed invalid card because it couldn't find a match for the card. So here we go, Dennis again. Dennis. Oops, hang on, did it again. It's faster than I am. There, okay, there's Dennis. And 9876. 9876. Okay, access granted. Now, here's an improvement over the last program that we did. The last program, if you start entering a code and stopped, it would never time out. It would just sit there and wait. So if you start entering a code and walked away and somebody else comes to enter the code, it would not work. You had to, it would say invalid after 2 key presses. This one's been changed. So let me just scan Dennis. I'm just going to take it 10 seconds. So there's Dennis. I'm not going to touch the keypad. And it's sitting here waiting for the secret code. And after 10 seconds, it says code entry timeout. So I'm going to enter a partial code. So I'm going to use Dennis again. Here, Dennis. And I'm going to enter, what was it, 9, 8, and I'm going to stop. I forgot what I was doing. I was going to walk away or call it away, something like that. And you just don't want to sit here because it's going to be waiting for Dennis to enter a code. 2 digits in, you're pretty good chance, a better chance of getting it. So code entry timeout at this point. And we'll do the other one here. This is Michelle, and it's 2580. So we're going to go Michelle, and then 2580. So granted. Now, I mentioned before about a different kind of tag, and I'm going to use this one. This is mine that I use for other things, but it works fine with this. Let me go ahead and scan it, and I created a code of 1, 2, 3, 4 for this one. So I'm going to come down. All right, there's me. 1, 2, 3, 4. Okay, I was granted. And just to show how this all is still working as expected, I'm going to go ahead and scan this again. And invalid code. And we'll do a timeout. I'm just going to put in, I'll just put in a 1, that's good enough. And in 10 seconds it will time out. Code entry timeout. Okay, so now I have these other cards that are not programmed into the program, so it should come up invalid. It did, invalid card. So what you were noticing before where it said invalid card was you saw it getting garbage, and it does that from time to time. So see scanning tag, and you'll see here, and you'll occasionally see it say invalid tag. All right, so that's how it's supposed to work. And I'm going to show you another program then that makes this a little bit more probably real world, because you typically wouldn't want this turned on all the time and stuff like that. But I'll explain that when I actually get to it. But let's go look at the output of the serial port now. So the other thing that's happening, and you had the serial port in monitor mode, and you see right here 2400 baud, very important because it is at 2400 baud. But you can see as I was going through, I'm logging access granted, access denied, to what location and who tried to do it. So you can see right here, denied, granted, 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 and then I was denied because I put the wrong code in. And so this is like if you could take a serial printer and attach to the Arduino, it would log everything that's going on the lock or the entry system or whatever you want to use it for. All right, so let's hop over here. I'm going to take this off to the side and look at this program. This is a lot more complicated than the last one we looked at. So let's go on down here. And the one thing I didn't hook back up from the other example was the green and the red LEDs, although they are still working. So if you would look at the other episode, you would see how to wire up the LEDs, and these are still working. I basically took the other program and just pretty much added to it for the most part. So if you wanted to hook up a green and red LED, you do that on pins 12 and 13. And here I define the RFID enable pin as pin 2, the same as the other project we were looking at, just so it was easy to upload code. And now here's where I define the actual employee information. So I have number of employees is 4, and I have, these are the tag IDs of the card. So if we take a card and you scan it with the other program, it gives you the code back. So this is my little thing that's on my keychain. You see it's a completely different address than what the other ones are. And then it's the first name, the last name, and then the secret code. So here you see the 4 employees, Mike, Dennis, Michelle, and John. And actually I spelled his name wrong. Let me fix that. So you see their badge ID or the tag ID when you scan it, first name, last name, and the secret code, which is what I wrote on the tags as a demonstration. Now, we're using a couple other things we've talked about in previous shows, one of them being state tables. So what we're doing is basically have 2 states. The first state is we're waiting for a card to be read, and the second state is waiting for a code to be entered. So I define current state, and I default to waiting for tag ID. And then I define the constants of waiting for tag ID and waiting for passcode, so that they're easy to reference later on in the code. Then we come down to miscellaneous global variables, and we have our code used to store the secret code of the RFID that was read. So basically when we read the card, we set our code equal to the secret code of the person. And then these are all used to remember of the code input. This is used when we read the card. This is the tag ID that when we read it. So these are just variables that are used throughout the program that are global for the most part because of the way it's working. The bytes that we've read in, that's part of the code read. The current employee, when we find an employee that matches, we set this variable so we can refer to them later on. And this is our timer variable for using the code entry timeout. Then we define the location name. This is just, only thing it does, it prints out on the serial port where they're trying to get into. So if you were printing, you had multiple of these and you're trying to print out to a printer, you could look at the documentation, you can see where they're trying to get into based on the log. Then we define the keypad like we did in the previous show, and the row and pins as in the previous show. And keypad, again, if you want to know how to use the keypad in a little more detail, go to the previous episode. We talk more about that. We define our LCD, and then we do our LCD init, and you see a couple of delays in here. I've been experimenting with this particular LCD. It's a little flaky sometimes, so I was trying to put delays in here. Your LCD may not require that. In fact, you see I knitted it twice, which seemed like it helped it some as well. I don't know why. But continuing, serial begin, we start the serial port at 2400 baud. So it's the RFID reader ID. We define the RFID enable pin as output, which is pin 2. And then we're doing the green and red LEDs here, output, and we are turning them both off. And then we display the screen that says scan your tag, and we're done with the setup. Okay, so now we're getting into the loop area, and this is what's continually happening. So you see when we enter in, we have a couple of local variables, L, which is a looping variable, and employee ID, which is temporary employee ID as we're working through things. And then we get into our state table. Based on current state, we're going to say if we're waiting for tag ID, we want to make sure that the pin is low on the RFID reader. And may I come back into me? You can see that if I get it into the camera, how that was actually working. But this turns it into read mode because we're now waiting for an RFID tag. And we look for serial data. And as we find serial data, we're going to continue to read. If we see a header or what is a line feed, we say go back to 0 because that's the first character in the data. So we set it back to 0, and then we start reading data as long as it's available. And if we drop out of this while loop, if we see another line feed or a character term, meaning it's the end of the reading, or we get to 10 digits, whichever one happens first. And as we're doing this, we're basically storing into this code variable what we are reading in from the serial port from the reader. And if we get down to the bottom here and it's equal to 10, so if it's not equal to 10, basically it's garbage, is what that's basically saying. But if it's equal to 10, we basically want to null it at the end because we're going to do some string compares later on. We want to make sure it doesn't continue on in the memory space. So we add a null to the end of it. And then we call this routine called getEmployee, which returns the employee ID, which basically is the array element number of the employee that matched. Now, if none matches, it returns -1, saying nothing matched. So the first thing we're going to do is we're going to say, if it's -1, it's not a valid person. So we're basically going to turn off the RFID reader, display the invalid card for 5 seconds or 10 seconds, whatever it's set up for in this routine. We'll go back and look at that when we get down to the bottom. And then we're going to turn the reader back on again, and we go back and start all over again. However, if the employee is valid, we're going to store the employee ID for later use. We're going to display the screen that says welcome in the name, enter your passcode. We're going to change the state table to say we're waiting for a passcode, and we're going to set the secret code to the employee's secret code, clear any data that's on the serial port, and then we're going to set our timer for keypad input. So we go down and we set, and at the end of all this, no matter what we do, we set bytes read back to 0. So next time we get code from the serial port, we're back putting it into the location of 0. And that's it for reading in the RFID. So that's the state of, that's what we do while we're in the state of waiting for tag ID. Now, when we go into the state waiting for passcode, because we got a valid card, we're going to disable the RFID reader. So you'll see the light on the RFID reader go green, and I'll try to show you that to you a little bit later. And then we get into our previous code that we had about entering in keys. So there's a couple of things that we've added in here, and I'll kind of walk through it. So we say we get a key from the keypad, and if the key is not 0, which means the key is pressed, we want to reset the timer because the key was pressed. So my timer is equal to the current number of milliseconds since the Arduino booted. We're going to clear out the old asterisk data, and we're going to re-display it with the number of characters that are currently been entered. And then we're going to check and see if the key that was pressed matches the next value of our secret code. And if it does, then we're going to increase the position unless it's equal to 4, which means we've got a valid code the whole way through. At that point, we're going to do unlock door, reset our current position back to 0, and we're going to go back to waiting for the tag ID. And then before we get back into that, we're going to clear any extra data that came into the serial port while we were in this state, because it could get garbage, so we just want to clear it all out. If it does not match and the code's invalid, we are basically going to, well, one thing you mentioned here is a log employee. I skipped over that. We'll show you later on, but basically that's what's printing to the serial port, log employee. So you see current employee, and then true means that they were allowed to have access to it. So when we get down here on denied, we log the employee and denied access. Display the invalid code screen, set position back to 0, go back to waiting for tag, because we'd only want them to, if the code's invalid, we want them to go back and re-tag it again. So we want another tag, and then we clear out any garbage that's on the serial port. Now, if there is no key, so up here we are in this if statement, if key is not equal to 0, I mean a key was pressed, so when we do what we just walked through. But if the key is not pressed, I'm going to come down here and I'm going to say, I'm going to add 10,000 milliseconds or 10 seconds to where I was the last time I set my timer. And if that is less than or equal to the current number of milliseconds, then they didn't enter anything for 10 seconds. So what I'm going to do is I'm going to show the code entry timeout window, or just screen, start all over with code entry, change the state back waiting for tag, and clear out any garbage. And then we come down here and let's look at the get employee. It's actually very simple. We define our loop variable, which actually this stuff doesn't even need to be here anymore. If this makes it less confusing, which I'm sure it does. Let me get rid of a couple of these commented out items. So basically what we're doing is we're going to loop through, setting our loop variable equal to 0, and while our loop variable is less than the number of employees, which is 4, and after each loop we're going to increment the loop variable by 1. Then we do a string compare. The tag ID is what we just read. It's passed in whenever we read a tag. So I'm going to compare that to the employee, the loop variable, and the very first element, which was the tag ID. And if they're equal, it's going to equal 0. So that means I want to return where L was. So I return to you what the, I won't call it employee number, but basically it's an element ID. And if I go through all this loop, all this stuff, and nothing matches, I'm going to return you -1. So that means I walk through all the employees, and what you sent me doesn't match any employee at this point. So if we go back up and look at get employee, where it's at, it's right here. I'm sending the code that we read to in the employee ID, and then here's where I look for -1. -1 means it's invalid card, so not an employee with that card ID, basically. Okay, so the other new one is log employee, and basically this is very simple. It basically prints the serial port, either access granted or access denied, depending on what this granted access variable is set to, and 2 in the location name. So in our case, it was, let me see, it was right here, it was 2, and I said, let's make it Studio A. So that variable is coming from the very top. We define it at the very top. You can scroll to the top, and we scroll down a little bit, and right here, location name. Let's make it Studio. You can make anything you wanted. So let's scroll down a little bit. and go back into where we were. So I'm basically saying access granted or access denied to the location name we just defined, for, and then the employee's first name, a space, the employee's last name, and then 2 blank lines. Now, I could have done this as a sprintf, and that would have taken the 2 in location name into 1 line and the 4 employee name into 1 line, and it probably would have simplified things. But we haven't really talked about sprintf yet, so I decided not to do that. This was kind of like the quick, dirty way of doing it. All right, so here's another new one. We're going to clear our serial port, and it's actually very simple. All this does is while there's data on the serial port, it reads it and basically throws it in the trash. It just reads it and doesn't do anything with it. So it keeps reading it until there's no more data, which effectively clears out all input on the serial port. So we do this quite often, and the main reason we do that is because of the garbage that we're getting from the thing. In fact, actually, while I'm sitting here doing this, I'm seeing it saying access denied because of invalid card or whatever on the over here on the side. So it's sitting here doing it while I'm sitting here doing this. But there you see invalid card. We just did that. Unlock doors, the same as we had in the other project. All this stuff was copied from the other project, with the exception here's code entry. And all it is another output saying code entry timeout. We just display this when we time out. And then here is the tag screen, and then the code entry, secret code, and then here's our clear screen, which basically bunks out each line because clear screen doesn't work right. All right, so that's the quick walkthrough of this program. This will all be on the show notes, and I want to talk to you in a couple minutes about another version of this program. I'm actually going to show it to you so you can see how I think it probably would be more in the real world compared to what this one is. So, but for now, I need to tell you a little bit about one of our sponsors. We have a new sponsor on the show, and it's Ting. You probably saw that in the very beginning of the billboard in the beginning. And Ting is a new kind of mobile phone company. They're really, really awesome. No contracts, so you can like sign up and quit anytime you want. Add new phones. You can add a new phone to your plan for as little as $6 a month, and all the minutes and everything are shared. It's a great service. We've been evaluating some of our services now, and looking at Ting is the way to do it. Let me go over here and show you why Ting is so great. First of all, they're great rate. Their rates are awesome. Like I said, $6 a month for a phone, and you only pay for what you use. So, and there's no overage penalty. So, say you wanted 300 minutes a month, and for some reason this month you've used your phone, and you've gone up to 600 minutes or something like that. There is no fee. There's no fine for that, and there shouldn't be a fine for that. It's your phone. You shouldn't be fined for going over that. They basically just jump you up to the next level. And without any penalty. And then next month they bring you back down again. So you basically pay for what you use. And on the months that you do not use, say you bought 600 minutes and you've only been using 300 minutes or less, they'll drop you down to the 300-minute plan. And so it's like you only are truly paying for what you use. Multiple devices on one plan. I mean, you share the data, you share the minutes, you share the texting between all your phones. It's a great thing for small businesses. There are no fees or limits on usage at all. A ton of free features, everything you would expect, and even some that you wouldn't expect that other big carriers don't do. Tethering and hotspotting is all included with your Ting. And again, no contract. So there's none of this. You want to get out like a couple months earlier, or go to another carrier or whatever. There's no contract, so there's no penalty to get to move to another company. You can add devices on. Think about devices like maybe your mother doesn't like cell phones, doesn't carry one, but you like to have her one in her car because she ever breaks down somewhere. You can get her one for $6 a month. Stick it in her glove box, and say, "Here's the phone if you ever need it for an emergency." For $6, that's cheap for peace of mind and stuff like that. So, yeah, very, very good. You can bring your own devices. They're expanding this. They basically run on the Sprint network. So if your phone works on the Sprint network, you will have no problem bringing your own devices. They have very inexpensive phones to buy as well. They have geek-powered customer support. So when you call somebody, they're not like calling the other carriers where they're just somebody off the street that has a script in front of them. These are people are, not to mention that they're not only smart and they know their products, and they cover everything. They don't put you on hold. Between 8 a.m. and 8 p.m., they will not put you on hold. In fact, if you call, the phone will ring until someone picks you up, and you will have that person until the end. There is no such thing as a hold with Ting. And that person is very empowered. It isn't to go talk to my supervisor. They can take care of you on the spot, no problem. And if you ever worked with Two Cows or Hover or any of those people, this is a Two Cows company, that their support is just awesome. I mean, this is the Hover support's just as good as the Ting support. So this is their whole thing. They're a support-oriented company. They very much speak Android. I don't ever see a mention of iPhones. That could be coming soon. I don't know. Never really asked them. But they got great graphs, easy to read bills. Like I said, there is no contract. Let's go look at the rates. I mean, the rates are just amazing. Let's see, plans. So let's see, here's a calculator. Say you do 500 minutes a month, and if you don't, maybe you do 100 text messages. So you're not a big text message person, and let's just say maybe 500 megabytes. So right there is $31 a month, and then it would be each phone's an additional $9. So yeah, it's crazy how cheap things are. In fact, in the case of the emergency phones, you would probably be actually down to $6 a month, because you wouldn't have any minutes on an emergency phone. If you the month that you used it, if it was less than 100 minutes, $9 a month. What kind of, and that's just like amazing. So here you see how many devices you want. So let's say you have you, your wife, and 2 kids. So there's 4 phones. We'll go back up to 500 minutes, a gigabyte. I'm sorry, that's text messages. Well, kids these days, it's up to you to control them. Let's say a gigabyte, 1,000 megabytes right there. So $62 a month for 4 phones on the plan. That's just nuts. So yeah. And we talk about devices. You own the device here. There's none of this sending it back. There's no surcharges. So you can see right here, buy the phones. These are all good phones. Here's an S3 right here, but the phone is yours. I mean, there is no contract with this. Like I said, take the device with you whenever you want. Here's some feature phones. You can have data. Here's the data. It's awesome. So what we worked out with Ting is if you go to tech-zen.tv/Ting, they will actually give you $25 off. That's our newest sponsor, and we love having them as a sponsor. They're great. They are basically, again, they're Two Cows, Hover. We use Hover here for stuff, and the support's just the same. And that's just awesome. I mean, they're a really great company to work with. Plus, they're on the Sprint network. So Sprint network's growing like crazy. So anywhere you have a Sprint, and there's good coverage maps on there as well, and they're everywhere. So, all right, that's Ting. And so now I want to get back over to another program, which is basically the same one we just walked through, but probably more of a real world scenario, because you wouldn't want the backlight LED to be on all the time. For a couple of reasons. First of all, it's not very power efficient. It's probably, I know they're LED backlit, but or maybe they're not LED backlit. Whatever the backlight is, can probably go bad in time. If you have somebody who's looking to get into your building, you don't want to show them where the card reader is at. You don't want to make it obvious. I mean, they're going to be looking for it anyways, but that just makes it even more obvious. And it's telling them what to do as well. So you could put just the display and the pad out there and the reader, somewhere close to it. But there's no reason to have the display turned on. The other thing is, if somebody gets a card, like one of these cards that's invalid, you would want to tell them that you can read the card. Because I will tell you, like, other cards that I have and other RFID things do not work with this. So if you tell them the card's invalid, that tells them that it can read the card, so you know what kind of system that it is. Where my other cards don't give any data at all. It is nothing. So you wouldn't want to tell them that, yeah, the card is readable by us, because that way they could figure out what the technology is and gives you an extra step. If somebody really wants to get in, it's some of the things they're going to look for. So what I've done, and I'm going to go load it up here really quick. All right, there we go. And I need to unplug the Arduino. Or not the Arduino, but the serial port on the Arduino, just because I need to upload this. So I'm calling this one the two-factor real-life example. And it's uploading. All right, it's done. So let me plug this in. And let me go turn on the serial port. And basically, in simple terms, it's actually less of a program than what the program is we just did. Now let me go switch over to the Arduino. And I have a card here. Here's John. You see the display is blank right now, not even turned on. So I'm going to take and I'm going to scan John. And it says, welcome, John. Please enter your secret code. Of course, John's secret code is 1245. So let's do this. It's 1, 2, 4, 5. Access granted. And then we go back to sleep when we're done. So it's turned off. So we're going to do a timeout thing. It's going to scan John. There's John. And he'll time out in 10 seconds, and then they'll go dark again. Go to true timeout, and then when it's done with this, we clear the screen and go blank. So here's a card that's not valid. It's not registered, and in the old system we would tell you it was not registered. See? Nobody can tell. So even if this was a former employee who lost their card, or as an employee card that's disabled and lost it or whatever, somebody couldn't grab this and go check to see if it worked with you or not, and they wouldn't be able to tell what technology you're using, because there's different kinds of RFID. And I'm not quite sure which type this one's using. I should have looked up before I got on the show, but I didn't. So again, you can see it's not working. So let me grab my keys. So here's my RFID, and I'm going to scan it. All right, there it is. Welcome, Mike. And we'll put in an invalid code. Invalid. And it goes to sleep, just like that. So let's go take a look at the computer here. And you'll see I have access granted for John, and then I was denied once I put in an invalid code. But if you look at this program, it is basically the same thing we had before with a few exceptions. One of the things that's different is you'll notice we commented out the LCD backlight, so the light does not come on by default. And then when we get into these states, while we're waiting for tag to be swiped, we say LCD no backlight, so it turns off. And when we're in the state of looking for a code, we turn the backlight back on again. And the other thing that we did is when we get an invalid code or an invalid tag ID, we just clear the serial port, assuming it's garbage. We don't tell them it's invalid because then they would know that we actually could read it. And we just continue on. So it looks to them like nothing's actually happening. So this is probably the more secure. And because we did that, there's a few things at the bottom down here we actually got rid of. We did not need... Well, we need invalid code. We still need unlock door, code enter timeout, code entry screen. So there was something in here. It was the wait for tag or something like that. I can't remember which one it was. Let's see. Can scroll down here and look real quick. So we just didn't need them anymore. So you'll see anywhere that was in use, it was pulled out. Invalid code, invalid card wasn't needed anymore. So we just took that out. And then there was code, no, display tag screen, the scan tag one. We got rid of that too. And basically all we do with that is we just do a clear screen in its place. It's because we don't want anything there at all. So we took that stuff out. We added in the on and off for the backlight, and that's pretty much it. I mean, that made it a lot more secure in itself, and a little bit more, probably more to real life on how real life stuff would work, like this. So that is pretty much it for this episode of Let's Make It. And as some of you probably know, I was actually not here next week. Last week, I was actually on a cruise in the Caribbean. And when I left, it was winter, and when I came back, it's summer. Today's supposed to be 90. But I'm still not quite with it. That's why I'm running a little bit late on this show. And plus, I ran into some problems with the Arduino, and I was tired and couldn't figure it out. And, you know, how it is getting back from vacation. The vacation from the vacation. So... But that's it for this week, episode 15. I do encourage you, if you're watching this on YouTube, to give us a thumbs up and subscribe. And then also do a share and share with your friends that are interested in this kind of stuff, because we like to get this community growing as much as possible. I've had some emails while I was gone, so if you send me email, I will get back to you this week. Some of them, I don't remember what they all were, but we're working with somebody also on a show, hopefully next week, on shift registers. Maybe try to get him on the show with us. I haven't talked to him about that yet, but that's a possibility. If you get the show through automatic download, or if you're watching it on a podcast, go to iTunes and subscribe so you get it automatically. But if you're getting it through iTunes, I do ask that you put in a comment, because it helps us get found. So many things these days are based on comments and ratings. And when you're starting a new show, it's so hard to get it started, because it's harder to get found with all the other shows and all the other noise that's out there, good or bad. But yeah, if you're getting it through iTunes, definitely would appreciate if you go out and give us a comment and a rating. Same way with YouTube as well. That's great if you can do that too. If you're getting us on Stitcher or something like that, they all do the same thing. We're available on Roku now. If you go to techzen.tv, you can go to the show notes, see all the show notes for all of our shows, so see all the other shows as well, and all the other episodes of this show that we just talked about when we did some of this stuff previously. So definitely a good place to go. Plus, you get all of our social information out there. You can follow us on Twitter, so you see when a new show goes up, all that stuff. We're very social. We're trying to be very social, at least. But it's all out there on the techzen.tv/Let's Make It, or you can go to letsmakeit.tv, either one. They're the same thing. And we definitely appreciate anything you can do to help us get the word out about us, because it's a growing community, but we like it to grow just a little bit quicker. And we definitely would appreciate your input on what you want us to do in the future. And if you've done a project and would like to send us some videos on it, we definitely would appreciate that too. We just show it up on here, and maybe we can get you on the air with us and talk about your project sometime as well. That's what's coming up with the shift registers. Somebody said they dealt with shift registers, and we haven't discussed that, and it's a neat thing to learn. So what we're doing with that is, it came from one of our viewers, and we definitely appreciate all that feedback. All right, that's it for this week. We will see you next week on Let's Make It. For show notes for this show, contacts, and more, go to the techzen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.